Solving problems by using acute triangle models. First of all, when we're looking at this, solving problems with triangles that don't have right angles, we need to look at a few other measurements that may be introduced. For example, bearing. Bearing is measured from magnetic north, so this being magnetic north, and we're going around in a clockwise direction. Now, we're going to look at page 302 for a bearing example. So let's look at this bearing example from your textbook. Looking at this, it says Steve leaves the marina at Jordan on a 40-kilometer sailboat race across Lake Ontario, intending to travel on a bearing of 355 degrees. But an early morning fog settles. By the time it clears, Steve has traveled 32 kilometers on a bearing of 22 degrees. In which direction must Steve head to reach the finish line? So we need to know in which direction, and we need to know for how long as well. So let's look at northeast, southwest, and understand what the question is saying. A bearing of 355 degrees means that you're 5 degrees away from due north. So, how come? Because when you go around bearing, you're going around for a total of 355 degrees, so that it's 5 more degrees to get back to north. Now, this race needs to travel for 40 kilometers in a 355 degree bearing. So, Steve there's an early morning fog, and he thinks he's heading in the right direction, but until that fog clears, he finds out that he's actually traveled at a bearing of 22 degrees, so in a different direction. So there's that 22 degrees in a different direction for a total of 32 kilometers. So he thought he was close to the end of the race when in fact he was heading in the wrong direction. So Steve basically needs to head back from where he is. This is where Steve is, back towards the end of the finish line. So if I can call this F for the finish line, this is where Steve is right now. So the idea is Steve is right here. Sorry, 1 second. This is where Steve is. And he has to head back in that direction to head back to the finish line. So we need to find out what direction Steve must head to reach the finish line. Well, on that note, let's figure this out. Now, note that this line continues. It's like a straight line going across. And this line, if you can imagine, is going right across, like this. Well, if I put my due north from where Steve is right now, we have to calculate his bearing from where Steve is right now. This is due north. This line is due north right here, and this line is due north right here. What you can note, that is that from here to here, from north to this black line, again from this north to this black line, it's going to be 22 degrees. And you can note that this entire black line from here to here is 180 degrees. And you can also note that this angle right here is the same as this angle right here. So if I know this angle that's right here, I can add that angle to the 180 to make this line, plus the 22 degrees to make this line, to find out the entire bearing it takes to get all the way around to where Steve has to head to the finish line. So let's do this slowly. First and foremost, we need to find out how far Steve is. So we're going to do that by calculating the value of x. X being this side right here. Okay, we'll call this x, or we could call it fs for short, but we'll just call it x. X is the direction in which is the distance in which Steve must travel. So x squared is equal to 40 squared plus 32 squared minus 2 times 40 times 32 cosine of 27. The reason it's 27 is, remember, inside this triangle, it's 22 plus 5, which is 27. 27 is opposite the x, and we have two sides on either side. So we have an angle contained between two sides, which means we must use cosine law, which is what we're using. So we find the value of x, this side right here. And we find out that the value of x is 18.5209 kilometers. Okay, 18.5209 kilometers. And that is this distance from here. So Steve has to head in this direction for 18.5209 kilometers. Now what we need to do is find out in what bearing that he must travel at. So we need to find this angle right here. To find this angle, we can use sine law. We know because we know this angle and this side, and we know this side, and we can find this angle. Because remember, if I know this angle right here, I can take this angle, add the 180 to get over here, that's a straight line, plus the 22 degrees, and that will tell me the bearing in which Steve must head. So, sine 27 over 18.5209, which we just found out, is equal to sine theta, theta being this angle right here. Let's put a little theta there for you. Here we go. There's theta over 32. Just a moment, folks. Let's fix that. It should be over 40. All right, let's redo this again. So the equation will be sine 27 over 18.5209 equals sine theta over sine 40. Over 40. Now we're going to cross multiply and take the sine inverse to find the angle. We find out the angle theta is equal to 78.6646 degrees. So we know that the bearing value will be 22 degrees. So again, we're up here at north. We're adding 22 degrees plus the 180 degrees it takes to go all the way around to here, plus the extra angle we just found out, theta, is 78.6646 degrees. So therefore, Steve must travel at a bearing of 280.6646 degrees for 18.5209 kilometers to finish the race. And that, folks, is how we would use bearing using trigonometric laws such as sine law and or cosine law. Okay, let's move on to another example. All right, so instead of example 1, we'll call this example number 2. And you're given a question like the following. A triangle tile needs to be cut with side lengths of 10 centimeters, 12 centimeters, and 15 centimeters. What angle measures are needed? Round to the nearest tenth. So we take a triangle and we put the measurements on there. And basically we need to find the angle measures within this triangle. So cosine of angle B is equal to a squared plus c squared minus b squared over 2ac. We find angle B by taking the cos inverse of those values, and we find out that the angle measure for angle B is 85.4593 degrees. So 85.5 degrees would be the angle measure that we need to cut for angle B. Now, to find angle C, we use cosine law again, use the cos inverse of that value, and we find out that C is equal to 41.6646 497 degrees. So 41.6 degrees to find this angle right here. Beauty of this is that we can actually now, folks, find the angle measure of angle A by using SATT. Angle A is 180 minus 41.6497 minus 85.93 degrees, and that, folks, will give us the measure of angle A. So when you're dealing with tiles and cutting them to lay tiles in your home, or let's say a pattern or design, a lot of times when they're odd shapes is that you need to have the measures of the angles in order to accurately cut the triangle the first time. Next, a temporary support cable for radio antenna is 110 meters long and has an angle of elevation of 30 degrees. Two other support cables are already attached, each at an angle of 70 degrees. How long to the nearest meter is each of the shorter cables? So this is what they're looking for. These are the two shorter cables right here. So what we need to use here is we need some information. So first of all, this is a temporary support cable and it has an angle of 30 degrees. Two other support cables are here, and each of these angles are 70 degrees. Now, we need to find this angle that's over here, and the reason we need to find this angle that's over here is that will give us some information that we need. So we know that the angle here is 110 degrees. How does that help us? Well, we now have a triangle that we can work with because we have two angles and one side. So we can determine the measurement of this side using sine law. How do we do that? Well, we use sine 30 over this side right here that we're looking for, BC, is equal to sine 110 over 110 meters. So these two right here, sine 110, the angle, over 110 meters, the side. And now we calculate the value of side BC to be 58.5298 meters. So that's this side right here. How long to the nearest meter is each of the shorter cables? Well, each of the shorter cables to the nearest meter is about 59 meters long. So we're able to figure that out. So one more time, folks. Even though we were not necessarily given the 110, we can find the measurement, and then using that measurement, we can use either sine law or cosine law to solve the problem. In our case, it worked out to be sine law. All right, folks, that's the end of the video. Have a numerical day.